Just as promised, I'm back again. This is a part 2 of the video, and this time around we're talking about a generalized form about what I just talked about regarding database backporting for web applications. So welcome again to this tutorial on database backporting, and I'm going to walk you through the process of safely copying production data to test environments, which is a common practice in software development. This technique allows teams to kind of test with realistic data while also maintaining security and data integrity. But let's start by understanding what a database backporting is. If you've not watched my previous video, that's fine. I mentioned it there, but I'm mentioning it here again. In software development, we often need realistic data in our test environment to ensure our applications work correctly. So backporting is the process of copying data from a production database to testing environments like development, staging, or even QA. The benefits are there. So some of the benefits are like testing with realistic data volumes, uncovering like edge cases that might not appear in or with the sample data, verifying the performance with production-like workloads, and also ensuring the data integrity across environments. I've had situations where I have to backport things because I got a requirement from the clients where we needed to test a particular automation, a new automation or a new solution, and we don't want to do that with production environments, and the lower environments was not production-like. So the backporting was very important for this kind of use case. So the backporting process really involves several key steps to prepare the environments and then stopping the application servers, running the backport scripts, data sanitization, and the obfuscation, restoring the test user access, restarting the services, and then verifying the environment. Those are the 7 different processes that are involved in the entire process. So this is very important. So before you start the backport itself, get approval from stakeholders and team members. We don't want to do that without getting approval. Schedule the backports during like low traffic periods because you don't want any kind of unexpected downtime. Also send notifications to affected users about expected downtime. Also ensure that you have the necessary access credentials if it's saved in either your secrets manager, your server arc, your whatever tool you use to keep your secrets. Make sure you have access to that. Create a backup of your target environment just in case, and then review any kind of compliance requirements for handling sensitive data. So the first step is pretty much stopping all of the application servers to prevent data corruption during the backport. Is very important. So for background worker processes, you can use the sudo systemctl stop application dash worker. For web services, you can use the sudo systemctl stop engines or the sudo system CTL stop Apache 2. This prevents any kind of active processes from modifying the database while also performing the backport. Next, we need to log in to the server. So the server is what will handle the backporting process, right? So this server should have the access to the production database backups. It should also have connection credentials for the target environment and also sufficient storage and memory for the operation. You don't want it to time out or you don't want it to stop. To SSH into it, you put SSH username at backup-server. The backup-server would be the IP. Use a password manager to securely retrieve your credentials. Never store passwords in plain text or in scripts. Once you are logged in, we need to update the framework, automation framework itself, or the scripts, just to ensure that you have the latest code. So you put in cd to the path of the scripts, and then you do a git pull, or even if you're using a custom script, you have your /, you can do like updates backports tools.sh, whatever you want to call it, but it ensures that you have the most current configuration and improvements to your backport process itself. Now it's time to run the backport process. You can use a terminal multiplexer like the tmux or screen. Usually any of them is recommended. I use tmux a lot, so I'll just mention tmux, TMUX, to ensure that the process continues even if your connection drops. So You do tmux new-s, you can call it backport, so tmux new-s backport, and then run the appropriate command for your target environment. So you do it like the ./backport.sh -- source equals production -- target equals staging, for example. Behind the scenes, like I mentioned in my last video, this typically exports the data from the production backups, imports the data to the target environment, applies any kind of necessary schema transformations, and also masks or obfuscates the sensitive data and configures the environment specific settings. For security and compliance reasons, sensitive data must be sanitized, right? So you can run the sanitize script. So ./sanitize-data.sh -environment equals staging. This process typically anonymizes the user information, names, addresses, masks any kind of financial data, scrambles any kind of PII, replaces any kind of sensitive values with realistic but fake data, and also preserves the data structure and relationships. So after sanitization, we pretty much have to, or we typically need to add testing accounts back to the environment. So you do that ./restore-test-users.sh- environment equals staging. I will give you the script as well, but this ensures development and QA teams have appropriate access, test accounts have necessary permissions, and automated tests can connect properly. Then after that, now we can restart the services we stopped earlier. So sudo systemctl start application worker, sudo systemctl start nginx or Apache 2. After the backport completes, now it's time for you to perform the smoke testing of key functionality. Also verify that the database integrity and consistency is there, and that the test users can actually access the system, and also confirm that the sensitive data has been properly sanitized. Send notifications that the environment is available again. If you do encounter issues during the backport process, typically I've had situations where people reach out to me and say, hey, I encountered XYZ things. Some things are like database connection failure. So just verify your network connectivity, check your credentials and your permissions, confirm the firewall settings as well. If you do have the issue of a missing database object, so just do a cat of your views _and _procedures.sql, and then the sed and definer. I can give you the command for that if you require it, to kind of figure out the missing database objects as well. And then data integrity issues, check foreign key constraints, verify that all of the tables were included in the backport, and also review any kind of schema differences between the environments. Also, for performance problems, make sure you monitor system resources during the process. Always monitor system resources, I tell you. You don't want to miss that, and always document it. Consider breaking large backports into like smaller chunks. Make sure there's enough space, like I mentioned. Optimize the database settings for import operations. To ensure full backports, I always like to stick with best practices, and I think I will do a better job to always talk about best practices in none of my audios or videos, perhaps. So document your process thoroughly, automate as much as possible, use version control for all of your scripts, test your backports process regularly, and keep security and compliance in mind. Monitor the backports process for any kind of errors. This wraps up our walkthrough of the database backporting processes. Remember, a well-executed backport provides a realistic test data while also protecting sensitive information. Thank you for watching, and I hope this has been helpful in understanding how to implement database backporting in your own project. Have a great day. Bye.